Thank you for joining us this afternoon. And I thought, since we are here in Vancouver and we're actually pretty close to Victoria, that I would thank you not just for coming here for the late afternoon, but the fact that I'm a Canadian. Today's actually a holiday. So those who are Canadian in the audience, should be taking their long weekend. We got a couple here. And I actually did go recently to Victoria. You can see me there, actually seeing her out on the island. So that's what some of us should be doing this afternoon, is just enjoying their afternoon. So I do really appreciate all of you, especially the Canadians, for joining us today. So I'm going to talk about the future of telco being open and what we can do with that open telco that we talk about. So first off, we'll kind of just start with, the conversation that everybody's been having at this event, all week long, and every event I go to, is that agility is the word they all talk about. So I thought I'd take a look at, okay, what's really agile out there in the animal kingdom? So I picked two of these animals here. Got the leopard, we got the big gorilla. So which one do you think is the more agile of these two? Right? So most people are going to say, I think it's the leopard. Well, the reality of this question is actually the fact that if these two actually got into a tango, the gorilla is going to win, right? Because with one swing, he can actually take the leopard out as he's attacking him. So how's that relevant to telco and kind of business? Well, it's about not just being fast, but being fast at the right point in time, because it's all about time to market and delivering services at the right point in time. So you got to think about which one you want to be. Just want to be quick, doing things quickly, or do you want to actually drive the market? So just to kind of, connect the dots to the animal kingdom. We've heard about some other kingdoms that we all want to get to, whether it's nirvana, a collection of clouds, the next heaven, the next Narnia, all those kind of things. So when we talk about open and what that means, a lot of people have, seen that it's, just all about software. But reality is that this is a complete culture, complete mindset, and it's about all the processes and those things that people actually do to run their business. And we actually talked about one. I was at an event last week at the IEEE talking about quality, reliability. And one of the things that came up there was when we talk about process and being open and being agile. So while we're doing all this agile stuff, what about the fact that I still have to respond on a regular basis to a RFP that's about this thick and a legal document that's probably twice the size? So where's the agile in that, right? So I came up with actually an interesting option for that. Maybe we actually, just like with images, we use AI to actually look at images and detect all of those. Why don't I actually use that for documents? And there's some of that actually going on, and use that for legal documentation, right? So I can use AI to actually figure out what the legal changes are, so I don't have to spend months with lawyers figuring out what to do with it. So that's what I mean by this is all about making sure that the entire business is open, from a mindset to a process to the tools. So with that in mind, I think we've seen this journey, ask the question many times, what is this thing going to look like, right? And Margaret talked a bit earlier today about the different types of clouds and different types of infrastructure. But when it comes to a telco, right, they're starting, some of them are still pre-LTE, but for the sake of argument, they're on this journey between LTE and 5G, right? And it's a journey of centralized deployments to edge, right? And there's all kinds of services in the middle there that we all know the acronyms to. I'm not going to take them all through, but it's the business services, the mobile services, the machine-to-machine, whatever I can do with multi-access edge compute, all the way through. And the key here is that the infrastructure we're talking about, when I talk about physical, a lot of people just think this is a physical server, right, in the land of cloud. Right? In the telco world, that's actually the physical appliances they already got. And some of those aren't going away. Right? Then you got the virtual, VMs and containers. Then you got the private telco cloud. And depending on how you look at it, when I listened to Margaret earlier, she talked about, is it really a multi-cloud or a hybrid cloud? And is it just you using multiple clouds to play, or do you actually make them integrate? So that's kind of why I left it as multi-cloud in the telco space. And any infrastructure is what we mean by that. So this allows us to potentially run any service, any application on any of this infrastructure and distribute it. That's the key, right? Because this is going to become a very distributed compute architecture. So that picture tends to look a bit like this, rather complicated actually, right? So you've got the service providers in the middle, right, with all the endpoints, 5G edge, access compute, mid-sized data centers, and POPs, and they're kind of surrounded by the different public cloud players, right? So this is kind of what's going on. And then you've got CDN caching to deliver video services, and then all of this sets of services, whether it's business services, whether it's the mobile services, they have to actually interconnect through this intersection, right? So this is really kind of the world that the service providers are trying to live within to deliver their services out of their networks and deliver connections to allow you to use any of the public providers. So really kind of one of the things that we're trying to figure out is how do we actually enable this to deliver all those services and run the business, right? So that's why we came up with what we call the Open Telco, and it's really about 3 building blocks. And those 3 building blocks, in most businesses, there are 2 building blocks that people worry about, right? They worry about their applications. That's what all the developers want to do is develop their applications and take care of that. But then if I'm a business, I actually have a lot of data. That's the data management platform, and I run my business on that, right? Because as an enterprise, I don't really worry too much about the network. I'll go buy some circuits from a telco, and I don't really care, right? I'm just kind of done. But if I'm the telco, his business is the network. And the only platform he actually worries about is that network infrastructure platform. And so for a telco, he really has to connect all 3 of these together to actually deliver the business, right? To deliver the services, take the data from that information, and build his applications and services on top of that, and build that feedback loop between all 3 of these platforms, right? So that's really what we see the evolution to go do this. And of course, these platforms have to be open, and they have to communicate in a common fashion. But it's all about interoperable APIs, not just APIs just for the sake of APIs, but ones that actually provide information flow back and forth. So the other thing, just to kind of put some context on it, so we'll take a really simple diagram of what the mobile network looks like. And the question here is, where is the edge in this picture, right? So we talked about this one as well a lot. And so some people think, the edge is their data center, they're done, right? Some people think it's out of the central office. Some people think it's out of the POPs. Some people think it's at the radio. So what's your answer on that question? My answer is it's my handset or whatever device I'm using, because that's where the application actually starts, right? The network happens to be underneath it, so we actually have to help deliver that service to those handsets, right? And while we're doing that, and we apply virtualization to this. Now, I was asked, actually, when I was asked to talk at this event, to talk about NFV. I said, that's kind of a little limiting of a conversation, right? So virtualization is being used, but it's only one of the things that's being used. So we virtualize various pieces of the puzzle and move them closer and closer out to the edge of the network. But while we're doing that, so we got that common NFV layer. Again, this is now going to evolve to VMs and containers. But in order to actually control all of this and make sure we actually take care of all that information that's in here, I need what's known as a common feedback loop that's common across this entire distributed architecture, right? I need some kind of messaging bus. And you've seen various architectures in ONAP, in Acrino, wherever those projects are, that they're looking at using real-time messaging to actually solve some of that automation. And sitting above that, again, an automation layer that's common, right? So that's kind of the picture we're looking at. So if we kind of dig into one of the platforms, right, and sort of say, okay, so what does that network infrastructure platform look like, right? So what you've got is, you got the physical pieces, you got the mobile networks, you got smart devices, and you've got, the typical, operators, sets of services that they deliver, where the resources are, where their services are, where their customer is, and their analytics. So what you're doing is you're making it so that you can actually interconnect any of these things to a common real-time distributed bus to actually publish information that you need, whether it's about the VNFs that are having events, your service assurance pieces, whatever information you need onto that bus. So really, this is what the evolution of the network infrastructure platform looks like, and it, of course, has to be through a common management automation platform. So let's jump to the data platform. So this is where you actually take all that information in off of that message bus on the left-hand side of this picture. Right? So you bring that in and go solve that. And this is where you actually start building your applications, and you apply business intelligence and data science to it. But you actually got to take care of your data and your storage of that data, and how to actually take advantage of that data to change my services. Right? So that's really kind of what this picture is about, is actually connect those dots, from the network and actually take advantage of those to actually apply that information, that intelligence, to run your business. And the thing you're going to do with this is things like your automation of your services, the changes of those services on the fly, but you might actually use this to change the capacity of a network or to change how your services are being delivered. To say, okay, I don't like this service, so why don't it's not actually being sold very well, so this one's not doing too well. And as a result, you want to change that on the fly. So you'll take this platform to take care of that. And the last platform is the one that most people have in their businesses already. And this is where you actually run whatever applications they are, right? The ones that most telcos already run is their back office systems, right? OSS, BSS, right? But now you're starting to see other applications inside the telco, right? Whether they're doing cybersecurity, whether they're doing IoT, their new multi-access edge applications, their Spark analytics, those kind of things are now being added into that application platform. And this is where the developers actually run and build those applications, right? So once we kind of got those three platforms together, let's go take a look at how the evolution of automating this entire picture looks like, right? So we're going to kind of jump, I'll say probably a few years ahead to where things are going to go. But if we sort of go back in history, right, to back when we had voice, video, and data as three separate networks, right? This is kind of the same picture all over again, right? What we have is we have a physical set of infrastructure, we got our virtualized infrastructure, and we got our cloud. So we now have three flavors, and we now have, typically what's gone on is we have three different domain-specific orchestrators, and we have scripts of different types to actually go push that into this infrastructure, right? So that's kind of where we are at the moment, is kind of in the process of building to this, again, a verticalized approach between my physical, my virtual, and my cloud, right? We haven't connected the dots yet, right? So where we want to get to is the one on the right-hand side, where you actually can combine that and go between these virtual central offices, those virtual edge sites, right? And use software-defined infrastructure to place, through business intelligence, these applications, these workloads, where you need them, when you want them, and where the customers actually want those services, right? So we're going to turn this very centralized approach that we've had for years into a very distributed collection of clouds. And the reason we're doing this is so that we can get those services closer to the customer, solve for some of these types of use cases where the service really does need to be delivered out of the edge, and just deal with the fact that, as we move to the world of 5G, we all know those radios only go about 200 feet, right? So compared to 5 or 6 miles. So I'm going to need a lot more radios collected up in a little cloud to actually deliver my service. So I kind of don't have a lot of choice but to build a distributed architecture. Right? So that's kind of the picture we're going to head to. So now let's connect the dots between those three platforms. All right? So there's your devices on the left-hand side. And I really have simplified that picture on the left. I mean, most people look at that and go, well, it's just one box of network service elements. But reality is there's tons of things there, from the access to the service to the subscriber management pieces. But in essence, all those physical elements and network elements, physical or virtual, are providing us some payload and providing us telemetry into the middle platform, right? And that middle platform is really where we have that distributed message bus to actually collect the data, massage it, convert it, and actually store it. And then as I want to actually get it back to the business, I've actually got to run it through various transformations, API management, because we have multi-vendor here, so I can't exactly expect that I'm going to use one API to get from the left of the picture to the right of the picture. And all of this has to have some sort of rules engine built in place so that I can actually handle those events and apply my algorithms to control the data that's in the middle of this, right? And just like the previous picture, right, I showed that there's a common management automation set of tooling across this that covers the network side, the data management side, and the application side. Because I want to actually be able to use common tooling across my entire business. And then you have the platforms underneath that are open, and those kind of platforms are your existing physical ones that you've got with APIs to those, as well as your OpenStack, OpenShift, Kubernetes type platforms for VMs and containers. And this all connects to the applications that you're running. So what you have is a feedback loop mechanism and a common set of tooling across your entire business. Right? So this is kind of the picture that we've been talking to our customers about. How do they actually go and expand their business to do what a lot of other customers have done on the enterprise side, in finance, in manufacturing, et cetera, who have built these two platforms on the right-hand side for their business. We're just connecting up the network side of this picture to an existing business. So with that, kind of the picture we want to go look at is what can I do with some of this stuff, right? So, I figured why not just talk about some of the different use cases that we have. I could do, probably 15, 20 of these, but, we do know we're kind of running up to the end of the day, so we'll just kind of pick a few. So we'll sort of take a look at the traditional picture of, what is MEC 5G, and it's really about 3 types of use cases, and that's really how 5G is being built. It's being designed for use cases, and there's different types, right? So the main one that most of the operators are looking at is, how do I get enhanced mobile broadband, and how do I get to customers where I don't control the access to that customer? So they'd like to kind of go drop some wireless technology in and say, okay, this guy's got a fiber connection, but I just dropped in some radios, and I can now access that customer directly. So that's what some of them are doing, is trying to find a way to get to customers where they don't have footprint. And that allows you to do the higher speed things that you want to go do at the edge of your network. Right? The other two, of course, are as we look at adding machine-to-machine in high volume, and even to the extent of potentially using connected drones, that's the kind of thing we can do out there. The other one that, going to be interesting as we kind of look at things going on is, how do I get to this ultra-reliable, low latency kind of world? And, so sort of in that world, we'll just kind of, click a couple of things here, just to sort of, put the pictures on it, is we've got that new kind of experiences in the enhanced mobile broadband. We've got every device we can think of being connected from machine to machine. But even today, people are actually controlling really big trucks out in mines and places like that, and they have to have very precise, exactly where is that truck going to be at this instant in time, so we have a safety control. So that's where you're going to sort of see that low latency kind of question is in that kind of environment. And then of course we've got, how do we take advantage of artificial intelligence, whether it's for personal robots or for actually just using robotics for building planes and things of that nature. Right? So those are the kind of things that we can start to think about. So we'll start with one of the simpler ones that in some cases we've already seen incantations of this today with existing technology. So not all these things necessarily need 5G and don't necessarily need MEC. But we have the potential, if we actually push some of the capabilities, the caching technologies, closer to where the event is happening, whether it's, if you're in Europe, it's a soccer match. Here right now we're sort of between, either the hockey matches or the NBA are kind of playing. So we got those kind of events. We got museums already, taking advantage of this. And then you got potentially, well, why don't we actually make it easier for people to see wildlife so that, I happen to live close to here, so I can actually, go out in a boat pretty regularly and go see a whale. Right? But I don't live close to those. How do I actually get to that and actually have that experience remotely? Right? So what this allows you to do is to take advantage of that technology to bring that information and that content closer to where the venue is going to be and actually deliver that and put some, added content onto the camera of the device that I'm actually using. Right? So that's one of the ways that I can actually enhance the experience. Right? So let's go back to kind of the basics of, the business users. Right? So right now, a lot of times people have services, primarily connectivity, and those connectivity services are kind of backhauled all the way from the business on the left, right, over to where their corporate locations are. And the operator network's in the middle doing, the usual connectivity of VPNs. But, this doesn't get to the broad collection of customers that are out there. So what the operator wants to do is to actually get to smaller customers, and instead of using existing physical routers and existing, physical technology, to actually put these on using data center technology, using a micro CPE, and then taking some of the mobile pieces, separating them, right, between the data plane and the control plane, and putting them across their architecture using, again, data center technologies. And then they can apply other applications on top of that mobile gateway, and deliver these kinds of services to their end users, right? So they can actually deliver the connectivity and business applications for a collection of customers at a better cost point, right? It allows them to go effectively down market to the smaller businesses and do it in a more efficient way than they currently can with existing technology that is either currently physical, that's deployed out there now, or some of the virtual platforms that you're using in the center of the architecture, right? This allows you to deliver, voice services, business services, and, actually allows you to connect to some of that legacy technology we've had and in effect replace it, right? Because we've had them for years. We had PBXs in the past that people put on their premises to give them their voice services. Now we went to the soft switches, right? The people put those out there. Well, this is kind of a distributed soft switch to give you your voice over IP services, right? So that's kind of one of the next ones that I would say a lot of our customers are early in the middle of getting ready to roll this one out. They've kind of headed down this path. You've seen the Acrano project, you've seen the Airship project. Those are the kind of open source projects that are behind this kind of implementation, right, to actually help deliver this. Okay? So I just wanted to kind of, speak to that business services kind of conversation, and I'll take sort of the simple one, which is, okay, now I'm going to deliver some services out of, for the sake of argument, 10, 15 data centers. And what you've got there is you've got your pods in those different data centers, and you got your bare metal, as you heard from Ramon earlier. He's got his bare metal apps he's got to go deal with, right? So how do I actually control all of this dynamically and make sure that it actually integrates across my entire architecture? So if we kind of work our way through this in terms of how you would actually go about it. So probably a few years ago, what most people would do is, when it came to go building this kind of a thing, they would basically say, you know what, I can build this all and not use SDN at all, right? That was the initial play, right? So no SDN in this thing at all, just use OpenStack, use Neutron, and I'm done, right? So that didn't really get us too far in terms of scaling it across multiple data centers. And so we said, okay, why don't we put SDN controllers in? And the basic ones, what they do is they basically control SDN within one data center. They don't actually connect it to the wide area network to the other side of the country, right? So that's option 2, is I can just do what I call a ships in the night approach, which is I've got my data center SDN, and I got my wide area network SDNs, and they kind of go like this, right? Well, if I really want to actually place workloads wherever I want them and have that integrated in my networking, I actually have to integrate that SDN that's in my data center and the one that's actually in my wide area network, using BGP, MPLS, those kind of things. So that's option 3. Integrated SDN between the vRouters, VLANs, SDN in the data center, and the wide area networking ones that are getting me across from my 7 to 10 or 15 data center locations or POPs. Now the one I didn't show on this picture, but it's a desire of some of our customers, because this picture, if you look at it, really quite simple, but what's missing on it? And I show the pods, I show the bare metal apps, I show the SDN, I show the routers. There's something missing between those routers. It's called optics, right? That's what actually connects those babies together, right? So how do I actually get that wider network of routers with IP to actually be integrated so I can actually go request that I need 100 gigs or 40 gigs or 30 gigs for this application between the data centers? So that's option 4, right? Which some of our customers have asked us for, that they want to find a way that I can actually have the applications in the pods, request services, and have that be fully integrated and connected across. And if we go look at the people who build clouds today for themselves, the usual, the public cloud guys, they actually take advantage of the wide area version of this. They've got their own SDN in their data centers, and they actually use wide area network transport SDN controls to take advantage of the capacity of that wired in network, because in their case, since they're not telcos, they have to buy that, right? So they want to actually limit how much capacity they're using, right? So that's why I say that as we go down this journey of building to the edge, we've got to think about, how do I expand this picture, right? Right now I'm just showing it as simply, 1 to n, say 15, 20 different locations. Now I'm going to go to 10,000 locations. How do I deal with SDN to place things out at the very edge of this architecture, from this simple picture to that one I showed just before, right? So that's the next one. So can't have any of these conversations about building these architectures out and supporting MEC without being, to talk about IoT. And so in this one, right, you're taking that same architecture that I talked about and saying, okay, do I need to deliver the business applications and support those? But at the same time, if I've got a mine, I've got a city, I'm doing my connected drones, I'm going to need IoT gateways at the edge of the architecture that all send telemetry through the aggregation hub, and that information has to be integrated to those two platforms I showed earlier, right? To the application platform for the different verticals that I'm serving, right? And to the data management platform where I do my data science, my machine learning, have my storage of my information, and my rules engines to control this picture, right? So as you can see, if I really want to build these kinds of services, I need to actually take these kinds of pictures and apply it to my distributed architectures and build these platforms to talk to each other in a simple manner. So here's another one that was advertised, I think, fairly recently. If you've seen the commercials for this one, it's kind of a bit out of my comfort zone, personally. But basically what you've got here is that the doctor's over here on one side of the picture, and I've got a problem, and I'm somewhere on the other side of town, other city even, and I've got a paramedic that's shown up, but he's not going to operate on me. The doctor's going to do it remotely, right? Use a VR camera, use a robot, and actually stitch me up or whatever else it is. Now, the one I can actually probably get along with, sooner than later in this particular picture. That's why I've got the picture up there on the right-hand side of somebody with a VR camera taking a look at my eyes, right? Because that's non-intrusive, right? So I could expect that I could actually be somewhere, and have, somebody have me just walk up to a camera, and the doctor's way somewhere else, and they got a really nice picture of my eyes. They don't have to touch me. So they could probably do that one, and I wouldn't, find it be too much of a problem, right? So, but you still have to take advantage of that same architecture to deliver the right kind of application and the right kind of latency to deliver this low latency capability so that, as the doctor moves her arms, that robot does the right thing and stitches you up, right? So this is possible, but, as I say, I'm not quite there yet personally, but we'll see how it goes, right? And of course, we've got to have the video, high data rates, the right latency for that video, because we all know that when we're watching video, forget somebody using that video to actually stitch you up. You want to have no drops, no pixels lost anywhere, right? Because if that pixel is gone, he's going to go stitch you in the wrong spot, right? So another one that's very important, and again, this goes back to that question about, is this really a hybrid cloud or a multi-cloud? And so if I kind of think about where we are right now, I actually think it's still just a multi-cloud. Right? So what you've got here is you've got the two types of services that you might want to take advantage of as an operator. You want to say, okay, I want to go deliver these mobile services, your virtual packet cores, your virtual IMSs, SBCs, all that good mobile stuff. Your business services, your firewalls, your IPSs, your load balancers, and you're going to run those on your virtualization platform, and you're going to use storage, OpenShift on top of OpenStack, and use automation tools to control that with your management orchestration, your SDN. So that's kind of the one side of the picture. Then of course I've got my operations and my portals. I want to be able to actually have that so I have a way that I can control it. Plus, so people want to go buy a service, they want access to that portal so that those business apps they have access to. So that's the middle of the picture. But the other thing that a lot of our customers are doing already is that the portal that their customers are using, instead of just going to the one, we get them up there? Probably not far enough. So instead of just going to this one up here, he's actually going to the one that's on the public cloud, either here in Microsoft or here out in Amazon. So the portal that I go to go buy a new mobile phone, go buy a new service, I have two choices to get to it. So the operator's decided that his front page, right, his digital presence, if you will, is both on his own private cloud and in the public cloud. So I still think that's kind of, when you get right down to it, a multi-cloud, right? But everybody has their own opinion on these things, since he hasn't really kind of integrated those things except from he's using the same application in two different places, right? When they really get to the point where some of the services that he offers in his private cloud are actually delivered and executed out of that public cloud, then that kind of gets a bit more like a hybrid cloud, right? But this is kind of where we're starting to see these two worlds kind of actually become deployed. So just to kind of go back to what some people are doing, with this kind of approach to the, I'll call it the 3-platform approach. So a couple of our customers, and in fact you've probably seen the many pictures from AT&T on how they're using machine learning and all those kind of things and how they deliver their automation capabilities as part of ONAP and the things they're doing. But we've got some other customers that are looking at it and saying, well, I kind of need to do the same thing, so how do I actually do that? So what you've got here is you've got their data cluster with their big data pieces that they need, and they've got the tools that they need to monitor their multi-vendor network, physical and virtual, right? Pull the information out of it, publish it to a bus, apply analytics to it, control their platforms, control where does the traffic actually have to go, what's the right approach there, and then execute that back into the network. So they basically built that feedback loop. Plus, of course, they've got to have a portal, right? So they can actually handle the services, the workflows, the intent of what this service is. And this then connects, just as I said before, to their application platform, right? So this is really how our customers already started to take advantage of combining that network that they've got that's sitting on the bottom of this picture, right, to their cloud, and applying a common set of tooling and platforms to deliver those services and those flows, I should say, and apply that to the applications that they want to go do, right? So that's really kind of where some of our customers are doing it. One of our customers actually sort of took this approach, but he hasn't sort of really built that middle platform yet. So what he's doing is he's saying, okay, I'm going to do the data science piece of this puzzle, and I'm going to use my analytics on it. And what he's doing is he's actually communicating through the back end, right, to his OSS to go pull information out of his radio information from 3 different vendors. And he's using the capacity information and the data he's getting out of those systems to say, you know what, if I run these algorithms, I need to put more capacity over here than I have over there. That allows him to do up and down capacity, if you will, as long as he's got more to play with. Because obviously you can't just go automatically put a new radio on a tower. That doesn't happen, right? But I do have to have information in the database that allows me to go do this. So he's doing it right now in what I would call a indirect way through the OSS. But his application, his algorithm application, is a containerized application that can run on an open platform. And then he can start taking advantage of that telemetry we're talking about and pull it into a system like this one to turn this into more of a real-time system. So he's kind of started down what I call the indirect path, but he's headed towards this one, right? So just one more to kind of wrap it up. So the world we're kind of going to end up in is that we're going to have our edge cloud sites, our virtual central offices, and we're going to have whatever our applications are, our network functions that we want to kind of apply to the picture. I'm going to have a completely software-defined infrastructure, physical, virtual, containers, and cloud. And whatever service I want to deliver at the right point in time, I can basically drop into the right portion of this architecture. But I need information that applies that intelligence across the clouds, right? And have autonomous information so I get that feedback loop, right? So I can actually elastically scale the service, place it where I want it, and it becomes, in essence, agnostic of what's underneath, right? Because that's where we want to get to. So I was talking to a customer a couple of weeks back, and I was talking to one side of the house, and then I talked to the other side of the house. You typically at an operator, you talk to the IT side of the house, you talk to the network side of the house, and it's kind of 2 different conversations. And the basic thing that they want to do on the IT side, because they move very quickly, is they want to take the network out of the way, right? And what that means to them is they want to get the network to move as quickly as they move in IT, right? But I got to make it so that I abstract that network to go do that to make it agnostic for them. So I have to give them the tooling to make it look like this is just an abstraction, and that infrastructure looks and feels like code to them, right? So that's that's where we want to get to, right? And that's where people are heading to. But while we're heading down that path, we're just adding just a little kind of speed bump in the problem, which is it's not just 7 sites, it's not just 50,000 sites. If I go talk to China, right? For their virtual RAN, that's 1 million towers. Right? That's their problem, right? So we got to go figure out how to go do this at scale for that many endpoints, right? And that's before I even get to the IoT ones, right? That's just for the radios I got to go connect things up with. And so really what we're seeing is that if we don't build these intelligent open platforms that have commonalities in a horizontal way, it's really difficult to get to that scale problem and go solve that distribution. And so the world we're going to kind of want to get to is to build these experiences, no matter what we're doing, whatever business we're in, and make it ultra reliable, right? And make it so that it's not just for you and me, but it's for also all the objects that want to connect when and where that has to be. And the way that I kind of see this going is that it's really about collaborating about this to build this next generation internet in an open way. Right? Because if we don't kind of work together on it, it really isn't going to happen if we kind of just say, this is a proprietary piece I'm going to keep over here, not going to share with you over there. Because this is a very complex stack that we really want to make sure that we can actually accelerate how fast we get here. Right? That's kind of what I want to do. Right? So with that, I'm going to wrap it up there, and I'd be happy to take questions from anybody. I know you're headed to go for beer soon, so it's okay. Right. Go ahead, just take the mic, please.
Hi, this is Anil Rao from Analysis Mason.
Yes, sir.
So I saw you touched upon 5G and MEC use cases.
Yes.
You didn't talk about network slicing.
I did not.
As a term.
No.
And
actually,
could you explain why? And
it's
could argue on both sides.
There's arguments on both sides of it, and I was just having a conversation with a couple other folks on your team just before we got started here. And so network slicing, I think, will be relevant as we move on, and as we get to the point where we have gotten to the point where the congestion of the architecture at the edge of this network gets to that point. But we actually have to solve that scale problem of understanding how much control plane stuff I need to separate from the data plane and build this service-oriented architecture. But it's really, this is the next realm of QoS to me. So it's a technology choice to help make things more efficient. But until I actually have that congestion problem and I solve it so I can do it reliably, people are going to use distributed architectures and turn capacity up and down where they want it, right, before they get into saying, okay, this is an IoT thing I want to go slice, right? The other thing as well, the very important one, is that that network slicing thing is tied to the vendors who build those network gizmos, right? So until that becomes opened up, right, and so we can actually do this in an open way between all the different radio vendors, it really doesn't get us to where we want to go, right? So that's why I didn't talk about it a whole lot, but I understand where it's going, okay, and I expected to see it there, but it's going to be a long time before we see that deployed in any large-scale amount.
Okay, thank you.
Right. Any others? Oh, I think we're good, and we're going to let you get to the next speaker. I think I see Azar sitting there as well, so thank you so much.